Welcome to all. Today we are going to see the linearly polarized modes. In optical fibers, the core has a refractive index N1 and cladding has refractive index N2. N1 is very close to cladding in order to achieve high data rates. As the difference decreases, more light energy spreads into the cladding. Otherwise, this can be said as the light guiding capacity of fiber gets weaker, so the structure becomes a weakly guiding structure. That is the difference. Delta is equal to N1 minus N2 by N1. It is very small. That is very less than 1. So since it is a weakly guiding, the higher mode clusters degenerate into a linearly polarized mode. For example, TE01, TM01 and HE21 degenerate to form a single linearly polarized mode. See, the fields show the same intensity variation patterns, but they are polarized linearly with the same linearity. All the fields will have same polarization orientation. These polarization can be vertical or horizontal. This is your horizontal polarization, this is your vertical polarization. So the fields will be having the linearly polarized modes will have same intensity variation, but the polarization can be either vertical or horizontal. HE11 mode is known as LP01 mode. LP refers to linearly polarized mode. In here two index are there. That is, the first index signifies the variation of light intensity in the azimuthal plane. That is, this is the first index. It says about the light intensity variation. For linearly polarized mode, this turns to be 0 because the field intensity is constant at all phi for a given value of r. The second index, so this is your second index, it indicates the number of zero crossings in the light intensity pattern. The number of zero crossings is 1 less than the index. So, suppose this LP01 mode means the number of zero crossings is equal to 1 minus 1 is equal to 0. So, no zero crossings are there in the intensity pattern. And as the radius, as you move away from the center of the core, the intensity gradually decreases. So it decreases radially outwards. Similarly, this TE0M, TM0M and HE2M modes also degenerate to LP1M modes. LP1M modes, there are only one cycle variation. Since the index is 1, it has one cycle variation in the azimuthal plane. And what about the number of zero crossing? M minus 1 zero crossings will be there. In weakly guiding optical fiber, the dominant mode of propagation is the LP01 mode. LP01 and LP11 modes are the important modes. They are preferred for long distance optical communication. This LP01 mode propagates like the HE11 mode, and LP11 mode is used for dispersion compensation optical fibers. LP11 mode is created by degeneration of three modes: TE0M, TM01 and HE11 modes. Similarly, TE0M, TM0M and HE2M modes degenerate into LP1M modes. In LP1M modes, there will be one cycle variation in the intensity, light intensity pattern, since the index is 1, and number of zero crossings would be m minus 1. So this is the diagram for the LP11 mode. The combination, this is He21 plus Te01, give rise to either this mode or this one. Here one polarization, this is another one polarization. Then He20 mode plus Tm0m mode give rise to this either this polarization or this polarization. Then for LP01 mode, there is a degeneracy by a factor of 2. And for LP11 mode, there is a degeneracy by a factor of 4. So for LP11 mode, this is 1, this is another one, this is 1, this is 1. These are the degeneracy values. For LP11 mode, there is a degeneracy by a factor of 4. For LP01, there is a degeneracy by a factor of 2. That is either horizontal polarization or vertical polarization. Then, similarly, we can calculate the degeneracy for each mode. M is equal to V square by 2. M is the number of modes and V is the V number of the optical fiber. Thank you.